All right, recording. Okay, so what to say today? We've been spending time reviewing the CAD file, and we definitely understand that one challenge is that things change, and it's hard to keep repeating documentation over and over. We've been at this game for a long time, and every time we do a new build, we have to modify things. Maybe there are some interesting developments of how to automate all this. Keith, would you mind actually telling us a little bit about your cunning plan and just the concept there? Because I actually do see there's a lot of promise. The simple thing that we do already is things like, okay, there's an index environment where you can click on all the parts and make it easy to organize within as a combo of Google Docs where you link to the files and to the wiki. You can upload new files to the wiki. But Keith, tell us what a vision could be for a higher level of automation than that.
Oh yeah. So I was trying to figure out where the organizational process was taking place and all that kind of stuff. And I looked into FreeCAD is awesome. It's all Python based. So I wrote a couple of scripts that take the FSCTD file, the FreeCAD file, and I started pulling objects from the file into a database, right? So I have Postgres SQL database in the back end, and I just did an experiment. I just basically I took the SH7 model and created a hierarchy structure. So all the top level elements have children, and then they have children of children and stuff like that. And so I thought, oh, okay, so this is nice. What we could do is basically use the FreeCAD file as kind of almost like a standalone little flat file database, pull it into a real database, and from there we can in the future create like a web application that allows you to maybe not only display the model or certain parts of the model, but also programmatically generate the different pages with for each component or each section,
Mm-hmm.
right? And on top of that, obviously, the web page could, you know, uh, utilize, different tables from, say, Wiki or something like that, where users can like add their names to it. We can have input fields where, people could actually add materials or, different sized objects and stuff like that. So that gets saved back in the Postgres SQL database. And the really cool thing is that FreeCAD has these variable sets that can like that can contain metadata about your objects, right? So each component could have like a whole set of metadata associated with it. What phase does it belong to? Like what? Well, it already has like materials and stuff like that, but you can do lots of different kind of like stuff on your own. Who owns this component, that sort of thing. And so when you have that in the database, you could theoretically just recreate a FreeCAD file from your database object, and so you just have like a new FreeCAD file that you could reuse for the next time, or whomever can grab that, and then you basically have all of your combined knowledge, for that one SH session, combined in that file, right? And then, that can be broken out and, build a new page for a new set of people building, or for yourself if you're going to build with a group. You have like, easy like instructions on how to create kind of like this, web page driven model where everybody can grab a section. So I'm at the beginning stages of this whole thing. I want to do everything normally, like we're already doing, because there's no way no way I could build something like this in that short amount of time. And I'm mostly a database developer, so my UI expertise is awful. I'm sure everybody on this call could do a much better job than I could. So you know, I would love to be working with people, with a group of people as talented as yourselves, to do something like this in the future.
Yeah.
But I figured, you know, uh, if we do something like that, it can really cut down the bootstrap time for for a new build. It's we're not reinventing the wheel each time with with Google Slides and all that kind of stuff, and everybody's talents could be utilized in much better ways. So,
What language? So this database approach. What language would you actually use to do this?
oh, so the database, you can use any database, but Express SQL is open source, right? And it's a pretty robust system right now. So
Hmm.
just that's SQL, right? That's the language for that. Your the scripts that you're going to use to like ingest the FreeCAD file would be Python, or FreeCAD comes with its own little driver system, FreeCAD
Hmm.
command, that takes in a file. It's a Python file, but you have to rename it to like FC like script or something like that, which is just a
Hmm.
Python script. Um, but that like FreeCAD comes with all its own Python libraries, and you just have to kind of make sure that you have the Python libraries that allow you to connect to Postgres or any relational database that you want. And then the web page, you can use whatever, Flask, something modern. That's pretty cookie cutter nowadays. So
Okay.
yeah,
Yeah.
like technically not a huge lift, but it's just like diving into
Yeah.
the schema and all that kind of stuff, and knowing exactly what we need to record and gather. So
Okay.
that's going to be the hard part.
Yeah, yeah. So that's definitely a project. But I think it's inevitable that at some point we're going to automate this process fully. So, changes that we make, you can upload. Yeah, I mean, we automate that and it goes back into the core file, and we avoid all this manual stuff that we're doing right now. But let's talk about just a little bit. Let me share my screen for a second about the approach that's kind of like lower brow. I mean, look at this. So who did this? So is the person who did this on a file? So on the call here, LW Writer 004. No. But look at this. So if when I downloaded Wall Module 24, so I went actually to the SH7. I went to the CAD page. You guys are seeing my screen?
Marcin, I'm here, and I did that. I'm not sure what's going on there, but yeah, please enlighten me.
Lee, you did that?
Yes. Yeah,
Awesome.
I didn't look like that on my screen, but yeah, let me know what's going on there.
Good job, dude.
Well, no, that's that's pretty cool because, right there is an example of a thing where, hey, it takes a bunch of time to generate this thing. Okay, so let me put Lee Ryder. That's cool. I mean, you can, so say you open this up, and this is what pops up on my screen instead of just a blank file. I'm getting all this annotation, all this information, which, I mean, literally, that's almost as good as a technical drawing. Like you just have to say, oh, okay, that's that top plate. It's 6 feet 10. If you scroll around it and zoom in, you see, okay, the top one is the big stud on the side is the 8 feet 8 inches, blah blah blah, and so forth. So that's awesome. And then the question would be, okay, Lee, tell us about it. So can we do? Are you running a macro there? And tell us how we can access this and use this capacity. Go ahead.
I've got bad news. All I did was use the measure tool for the distance. I was
Oh,
doing that to get like the quantities, and then I
okay.
guess I just saved it in there.
Mm-hmm.
I was saving them as I went. So I guess when I uploaded, I did the hyperlink or whatever.
Mm-hmm.
It just threw all that in there with it as well.
Oh, okay.
That
Okay.
was all done manually, unfortunately.
So how do you get? I guess I'm ignorant on how do you get all the stuff to because when I do the dimensions, what is the process by which you get all the dimensions to show up at the same time? Can you just tell us?
So I just went through one by one, used the measure tool,
Mm-hmm.
and like in the task tab, and then when you click one, it'll give me the measurement. I'll just hit save, so it'll just lock that measurement there,
Mm-hmm.
and then go to the next one.
Okay. Okay. Would you mind sharing your screen to show us exactly how you do that, just for
Yeah,
everybody's purpose? everybody's benefit. So I'm going to stop presenting. Go ahead. Show us how you did that, because that's, I think that's useful. And then absolutely you can, somebody can make a script and automate that. Yeah, right away.
Let me see here. Window.
Mm-hmm.
Up. It says can't share it. I think I might have some problems with my browser and the recording.
Oh, okay. So maybe we can't. But so just within the measurement tool, you click on there's a menu item, or not menu item, but something in a dialog that says save, and then
Yeah, and I'm using FreeCAD 1.0.2. Yeah. So when you click the calipers, you just go to length.
Mm-hmm.
You click on the edge you want to measure. They give it to you, and then you get like the three buttons underneath: reset, save, and close. You just hit save, and it will.
I get it. Oh, I haven't been using the save. I was just closing all the time. Oh, that's pretty useful. Has anyone done that too? I'm just doing that on my screen here.
Yeah, I've been trying to do that. It's actually it's a little bit difficult, just because if you don't have your scales set, like the lines don't show. So you need to like update your preferences and your presets. And then also it's difficult if you're doing a 3D view, because you're not, you need to set your grid, your face that you're working with, or else the lines aren't gonna come up straight. And then you need to make sure that you're using your correct select tool, right? So you can't just select a face or a point. You need to be selecting like a vertices, or you could be selecting a point if you want to use that. But there's it needs a little bit of tweaking in order for it to be like readily available for everybody, I think. But it's a really good tool, because it'll give you the measurement right there. And I'm actually, yeah.
Are you saying it's a little buggy, or it's
no, it's just
getting used to?
It's
like, you have to zoom like way in to make sure you get the right thing.
Yeah,
it doesn't it's not like AutoCAD where to like snap to the endpoints or anything like that.
Mm-hmm.
You kind of got to get real granular with it to make sure you're selecting the right thing.
Yeah. No, that's great. And that could be automated. There's another person. So that was, who was that? I believe it was Robert, who produced a macro which does that, but automatically. So it just basically gives you that, but you just run the macro and it pops all the dimensions of that thing in there. So this makes me ask the question, what is, when we are organizing the part tree in a very nice way, like, step-by-step directions, or a way which is super helpful, where you say, okay, this is the kitchen sink assembly, or whatever, labels that are really explicit. And if in that folder, say it's a folder, you can put in all the right parts. I think there's a lot to be done with just the idea of organizing parts really well in a part tree, so that you can have automation such as, now produce a technical drawing of just this, or however we want to automate it. So there's a lot to that. I'm just talking about some of the possibilities of organization, where we're trying to go between the CAD files and indexing what's actually in the CAD file, because you can quite easily get lost in a CAD file if you don't know what you're looking for too. So, okay. So beyond that, I want to just show a little update. If you guys haven't downloaded the latest version, but download the latest version if you can right now, or also watch my screen. But I want to go through the roof assemblies. So I want to describe that a little bit. So we talked about walls, which are basically 24-inch on center framing. You've got 2x6 framing. Typically we use oriented strand board. So that is, conceptually wise, that is very important. So once you put say you're making a frame, it can still wobble and torque, and you can literally flatten it very easily. But once you put that OSB on and nail it off with either nails or screws, to the framing, that thing becomes a solid, super solid object. So you can't rack it, it becomes structural. And that's how we do the wall modules, because if you did that the whole house with the framing but no OSB, that house would collapse. It would be very susceptible to racking, basically like paralleling and just falling over in all directions. Because if you don't have that oriented strand board as that skin to bond it, literally to like a box, you convert it from, what's a good metaphor there? Like, I don't know. Think of like a, what's it called? A scissor lift, the thing that expands. It expands its framing, but it can expand quite far. But if you put a sheet that bonds all the, if you know what I'm talking about, a scissor lift, if you bond all the elements together, then it's solid. You can't move it. But that's just the concept. So on top of the wall framing, you've got top plates and then a rather simple roofing assembly. So I want to describe what we have done in a build. Typically, we've done houses that are 16 foot wide, and we can easily go to 20 foot wide because dimensional lumber, say 2x12s, are readily available, not too expensive, up to about 20 feet. But once you start getting any higher, you really get into high costs, so it becomes challenging. How do you address that? So for example, when we're building the hangar structure in which we're going to build the house, we address that by using trusses that are actually somewhat engineered I-joist-like trusses. And for the house build itself, what I did was use ChatGPT to actually engineer a truss that's similar to an I-joist, but it's a little different. And if you look into the file, you see that our joists are made of OSB and 2x4s. There's a top stringer and a bottom cord, top cord, bottom cord, and it has a vertical in the middle. The sides have two verticals on them. If you look at the CAD file, let me see if I can share my screen to describe this. Can you guys see my screen now? Okay.
Yeah.
So in this FreeCAD, okay, let me close out of that. So this is, we just updated the roof into, okay, let me go view perspective. So this is one of the roof sections, and that is in the family room, so you can either watch my screen. Ooh, how do I make my dimensions now go away? No. Okay, I've got those dimensions hanging out. I don't know how to get rid of them right now. If you look at the actual view of this structure, so I'm going to go into orthographic. From the top, I mean, you can't see what's going on. From the side, I'm going to start stripping down all the parts and start with the trusses themselves. Number one, the trusses. So actually in the file that you can download, it's actually numbered right now, and we start with the trusses. Look at that. Have you ever seen, so these are the trusses. They're tapered. This is definitely non-commercial. You can't get it. I haven't seen a tapered truss, but what you've got is top and bottom cords, 24-inch centers, 50 pounds per square foot load capacity. That's how they look. So this is OSB on the one side, and this is all 2x4s. There's a middle part, middle vertical 2x4. The rest is OSB, 8 foot, 8 foot, and 4 foot section in the middle. There's bonding plates between the sections of standard OSB, and that's how they look. So from the side, from the front, it looks like this. for one of the house sections, one of the 12 by 20 sections. From the top, it looks like that. From the side, look at that, it's actually tapered. And why? So this is actually a change we've done since the last model. In the last model, we did flat trusses. It's like, why? Well, everyone does flat trusses. No, trusses are flat. Well, no, if you do this, then we actually built in the slope for the rainfall, for the water drainage from the roof. Because otherwise what we did in the last model, so if you download some of the older versions before this upload here, we did tapers. So basically we cut separate wood on top of straight trusses to get that angle. Well, that's twice the work. It was actually hard to do in practice. So we just tapered the trusses to get the rainfall drainage. And you can actually go, I can show you all these calculations. You can actually verify this, but there's a particular reason for why this does work. Now the end trusses, they're actually reinforced because that's the outside of the house, and the one on the outside has another 2x6, I believe it's a 2x6 on it as a reinforcement. There's actually a couple of them. There's a reinforcement on the top and on the bottom because we're nailing it's a nailing surface for additions, or like for example, if the other section of the house is nailed to that, you have these nailing boards in this truss here, these long boards which are 2x4s, so that you have a solid structure to bond the two home sections together. Now this kind of a design this is not stock, first of all, because nobody makes these trusses. We do. I mean, we'll build them. If you don't do this, if you're concerned about codes, yes, that's an issue. If you're in a coded jurisdiction, you need to pass this by the inspectors. So we will, we don't have that yet. We will provide engineering, but if we don't have the engineering, you need to go back and fall back to the standard method, which would be, for example, 2x12 by 20s on 16-inch center. So if we have the ability to pass the code, i.e. provide the reference drawings, yes, you can do exactly this. If your building department says no, or well, they will not say no to engineering drawings, to engineering approval. They'll say, oh, okay, yeah, the engineer approved it, and so forth. So you do have a back something to fall back on in order to build this. But we really like these trusses. Now these ones are 20 feet and they have the slope built in, so you avoid any kind of other mechanism that you need to put in for creating a slope on the roof. Therefore, the whole wall sections of all the walls, they're just a box. And here you got these other components laying on top of that. Nothing of the sort of a riser or some kind of an angling mechanism which allows you to get that drainage slope. So I'm just saying this is what we will build. If you're building for yourself, you can definitely do this. If you are doing a build where you have building departments, you have to provide either engineering drawings or go back to the standard method of using 2x12 lumber or other standard joists. However, yeah, at an 8x times the cost, unfortunately. So if you build this yourself, you're about 8 times lower cost than off-the-shelf trusses like this. So this is what I'm saying. Whenever you are into cost reduction, you always have to think about, well, what could I do that saves materials and money and time? So we often run into just engineering our own stuff. Now, yeah, that's doable, but we need to still go through the steps of getting the reference drawings from supporting engineers, because a lot of engineers will not be comfortable stamping something that's a reference design, meaning they take the liability for that reference design. I think that's the way it should be, that an engineer doesn't have to do a custom job every time. Of course, you can put together reference designs that can help everybody. And these trusses, so for example, the hangar that we're building, in which we're building this the house inside the hangar. We've got 24-foot trusses, and we attach them to further trusses on the ends, so we end up with a 32-foot spanned space, 24-inch center, at a very low cost. I just want to share a couple of pictures from the current build. So this is actually what's going on. This is some of the first sections of the hangar. So these are 14-foot tall walls. What we did there is we did stuff like this. That's actually, we got some crew people. Some people are here already. We're building this stuff. But what happened was all this is built on the ground. This is I actually did myself. So I took 13 wall sections, 4 by 14 modules, pretty much similar to what we're building for the standard modules in the regular house. Put these other pieces at a right angle, and then did that. There you go. That thing is floating in midair. Just lifted it up. Had to reinforce it at the top. But it's actually pretty interesting because it allows, like, we've never actually done this so-called tilt-up construction. Now this is with a big machine, but you can do that and then end up with your structure. So that's pretty interesting. We're just doing that right now, and this thing's actually huge. Like the modules are 14 feet. I mean, man, once you put it up, it looks really tall. It doesn't feel that way before you build it. Okay, the trusses are actually going to span. This is the riser structure here that for the angle of the roof on the hangar itself. So when I was discussing the trusses, I said we built that angle right into the trusses so we can avoid that, because actually that riser there, that was a lot of work actually to actually build that. Okay, so yeah, I don't have too much actually to share today. Maybe we can go to some other comments and any questions that people might have. We're still, we can also practice on some of the, like for example, the breakdown. Oh, well, I didn't finish the trusses. Let me just go back to that a little bit. Go back to the, so I showed the trusses, but regarding the overall construction of the roof, this is sitting plain on the wall modules, load-bearing walls at the north and south. Number 2 is, so we can actually, these are 3 types of trusses. So 2 of the outside trusses are different. All the middle ones are the same. So that's different module in terms of modular breakdown. Right after that, we've got the front. It's an assembly of some 2x12, some more OSB, and 2x6 lumber. So that's that you cap the front and connect those all together. Now this, once again, talking about modular, we can build that. Just like we can build each of the trusses, 7 of them. We can build this thing. Then we can build the side as a separate module and then put it up there. Then, let's see, forgot about the back. That also can be built all at the same time. And once again, this is 1/3 of the house, so different teams can be building all of these at the same time. Then you got decking, so that's oriented strand board, 3/4 inch, which if you toggle the visibility, it has to end up, all the seams have to end up over trusses, which happens here. Like that seam right there, it falls on a truss, so this is a full sheet of 8-foot OSB. This is a non-condensing roof. It has solid insulation on top of it. So that's foam board insulation. We're going to put 4 inches of foam, solid insulation. And then there's some more sheathing that goes right here over the front, side, and sides. That's just 1/2 inch OSB to cover that sheathing layer, which stabilizes the whole structure further. Roof siding caps, which yeah, the details, this gets into some fine details here. There's before there, number 9 is the membrane. So there's a continuous roof membrane, that's the water barrier. So it's a membrane roof, followed by the runners for the photovoltaics. So this is to which we mount the photovoltaics. No penetrations through that. There's metal connectors connecting to the side of the house. So either just hurricane ties and straps on the front and back. The back gutter assembly goes in after that. Like this is the back of the house. There's the gutter assembly on this back here. Runner ties are so there's hurricane straps on the back. It's puncturing through the membrane, but on the side. So we use some roof mastic to seal up those holes, and butyl tape and roof mastic to seal up any of those holes. Same through that's the front side. The nails that go into the PV runners, they are 1.5-inch nails. There's no penetrations at all in the roof membrane, and that's pretty much the assembly explanation for the roof. Okay, so this is what we will build. We like the idea of the tapered trusses. That's definitely an idea. And as I said, if you want to do, maybe you don't want to build that, or you want to just use standard lumber, you can use 1x12s that are 20 foot long. They're still reasonable in price. But then you have to add the taper mechanisms so you get drainage, which we did last time, just using tapers that have about a 4-inch, I think about 4 or 6-inch rise. I think it's 6-inch rise over the entire 20-foot length of the roof. That's basically it. So with that said, I'm gonna stop presenting. Any questions on this? That's the assembly on the roof side. Richard.
Does that membrane last before it starts decaying?
Let's talk about that. How about 100 years? What are we doing? Pond liner. This is a landfill liner. Actually, it's called fiber reinforced polyethylene, 30 mil. On top of that is gravel. So the gravel is important for the purpose of preventing any UV degradation. In a UV that will last like 5 years, 5-10 years maybe. It's black, so it's got UV inhibitors, but that thing just doesn't last. For lifetime design, you're like 50 or 100 years. So if you bury that with some gravel, just a little layer, inch or two, you got no UV degradation. All the joints, including like the sides, are trimmed up, so there's no UV actually hitting that membrane, and that makes it a very long-lasting roof. It's actually twice the strength and half the weight of EPDM at about half the price. EPDM is a standard roofing, rubber roofing. I was Googling why nobody uses fiber reinforced polyethylene, and it's industry inertia, pretty much the reason. This membrane, if you're going to go to your building department, they're going to ask you for engineering. They're going to probably require a stamp, unless they are progressive. In which case, hey, one option is just use EPDM, what's already approved. Another option, get the reference drawings from us, which we're working on. So we haven't made we are, like Jeff, for example, is actually engineering. He's coming to the workshop. He's engineering the PV system actually for a reference drawing. That's A+. We just need more people, find more people that are actually willing to do this work. So if you know any engineers that are open-minded to do all this kind of work, then send them our way. That's something we want to do. Definitely for the cost of the legal cost. I mean, there's no reason why I should be paying thousands of dollars for permits for the engineering fees. It's ridiculous. So.
And
Marcin,
go ahead.
Go ahead.
I was gonna ask, with that gravel you put on the roof, are you adhering that some sort of
No,
way, or you?
no, it's locked in mechanically. So that's just pea gravel, round river rock, the small quarter inch. What happens at the bottom? There's a mesh that's at the gutter side that holds the gravel in. So the water goes through. The mesh holds the gravel.
So you don't have to worry about heavy rain or anything moving that around, leaving spots exposed as time goes on.
I don't think so. I mean, haven't seen that, at least in the roof that for this house we sold in Maysville. I mean, that's intact. Yeah. I mean, no. I mean, gravel. It's like um, we haven't adhered it. We didn't have issues yet. Are you saying that some people do that for the purpose of like the stuff blowing away?
Yeah, I was just curious if over time, you get a heavy rain, or you get it starts to wear like kind of
Mm.
low spots in it. Maybe it starts to wash some of that gravel away, exposes the membrane below, and then you have issues in those spots
Yeah.
as you glued it down or did anything to kind of hold it in place.
Okay. I think I was looking into that. I think at some other time, and the idea there was there's specific grades of gravel that are either heavy enough that they do not um, suffer from erosion, so to say. So you have to get the right type of gravel. This pea gravel, it's working for us so far. I mean, we'll see. I guess if we are so with the photovoltaic system, we are getting that engineered. I think they're actually checking the mechanical attachments. I'm not sure if they're checking that's the gravel stuff is going to be included in there. I actually don't know. That's it's a consideration, but we haven't seen issues, and we have some serious winds and rains here too.
Makes sense. I was just curious.
Hmm. Yeah.
I was wondering, are we using like pocket screws to fasten our boards together? Do we have enough pocket screw jigs to do that sort of thing? Um,
Pocket screws are used on cabinetry. That's where we do use that. Everything's structural. It's nails and screws.
okay, sounds
So,
good.
yeah. And once we get into the cabinetry, there's a little bit of pocket screwing that we do.
Yeah, I was wondering, do we have enough? I guess
If you
do we have
have
enough jigs for everybody?
no, we don't have. I mean, we have like a couple of them, so we
Okay.
could probably. Yeah, if you have one, that would probably be
Yeah, I
useful.
was wondering about that. That's the reason. Yeah.
Yeah, at the cabinet making time, that they will come in handy. Mm-hmm. Yeah. Yep.
Hey, I almost figured out how to use the tech view or the tech draw in FreeCAD.
FreeCAD one.
Yeah, the
Okay.
latest version,
Yep.
uh,
Yep.
and it's a little tough because the components are not scaled properly. So I'm trying to figure out how to rescale to add them to each document. But if I do that, I'll document it and just share that.
Yeah.
Uh,
Absolutely.
because like if you use a template, it actually looks kind of nice
It
and
does.
it's easy to create dimensions on it. A lot easier than actually using the trying to use the component and using the draft workbench.
Yeah, and once again, if we organize the file according to specific protocols, you can just automate that process fully. Okay, spit out the tech drawing for this and so forth. So, yeah, you're seeing that possibility too, Keith?
Yeah, it's just that the scale is off. That's all.
Mm-hmm.
So yeah, I have to figure that part out.
Yep. Yeah. Yeah. Excellent. Um, for any people that are on the call right now, I did miss one important question within the logistics form, which is how many people are coming with you? Because I think some people, I am not sure for some people if there's two people on the call here. Is there anyone who's got more than one person that they didn't put into the logistics form? Okay, I want to just make sure that we don't have any surprises where we have. Oh, because we also want to organize and plan role allocation.
Yeah, Marcin, I may have one more coming.
Okay. Are they? Wait, is that for the 2-for-1, or is that another person's just going to sign up?
Yeah, for the 2-for-1. That was the plan.
Yeah, yeah, yeah. Okay, so yeah, as soon as you know that, um, just let me know, and we'll accommodate that. Yeah, and Maria, yes,
Okay.
as well. Hmm.
And as far as accommodations, I guess the Hab Lab is off, right?
So
Too many folks in there.
there is, I think we're actually at 22, and I counted the number of beds, and we can actually fit up to 24. So I think we actually have 2 spots still. Yeah.
It's a if I bring a cot, can I just kind of
Yeah.
chill there?
Oh yeah, sure,
Yeah.
sure.
Oh,
Yeah,
sweet. Okay, great.
yeah, yeah. So for the actual
Another one?
hangar, we are, as it stands, I think the progress is going. We are still trying to put another bathroom in there, and we are planning on heat in there. So whether it's, I mean, we have 5 heat pumps we bought. We're gonna try to install as many of them as possible before the workshop, or maybe even during the workshop. We'll have five teams doing heat pump install practice. There's a lot of it is just plain, simple, just mechanical, just build stuff. But there's about an hour that you need, like, where you actually do the connection part, which is a little more complicated, but that's the learning part. Hmm. Yeah. So either the heat pumps, or we'll just get a bunch of electric space heaters. So we'll be warm in there. We got to keep warm. Yeah. Okay. So yeah. Anything else? Because we can probably quit here. Ben, what do you got?
Hi. Accommodations. I was wondering, is there a map of the farm anywhere?
Yeah.
I'm just wondering,
Yeah. If I can show you.
game that is.
Mm-hmm. Yeah. Let me share my screen just again, so just to know, so that all you guys know where to go, including Roy, who's coming tomorrow. Uh, so if my screen is being shared, take a look at this. So when you look at 909 Southwest Willow Road, Maysville, this is where we're at. It's called Factory Farm. Hab Lab is, you go right past the workshop. That's the workshop there, and then that's the
The
Hab
screen's
Lab.
not up yet, Marcy.
Say again.
Screen's not up yet.
Not up
I
yet?
don't. Your Google Maps isn't showing yet.
Would you mind going into the doc? It's telling me I can't share again. Keith, would you mind doing that?
Oh, yeah, sure. Sorry, I didn't have it up though. Does anybody have the maps up?
No, it's not up. So go to actually cut and paste a picture into the actual working doc that we were viewing.
God, sorry. Yeah, I did not. I was not paying attention. Sorry.
Oh no, no problem. Let me put a direct link into the chat so you can see what we're talking about there. Yeah. So if you click on that, that's my screenshot. Now that's a map, Google Maps, before a few things have happened. So we've built another structure, and we're building the hangar. So there's 2 buildings missing from that Google Maps at this point. But the Hab Lab is still the right place. Keith, are you working on that? No, you're mute. You seem to be muted. Oh, there you go. Yeah.
It should be up.
Factory Farm, 909 South Willow. Hab Lab is, you turn left after the white roof structure is the workshop. It's made of compressed earth block walls, and it's got the steel roofing. Hab Lab is, you turn left over there, and that's the accommodations. That's basically it. Now, where that long trailer is, that's the beginning of basically the whole bottom there is now going to be the big hangar, which is going to be 160 by 50 feet. So that's in progress right now, not shown on this map. See it when you get here. Yeah, yeah. But I do encourage you, yeah, just keep looking at the CAD and getting yourself familiar. And I can cover a couple of the systems, like the modularity of the heat pump, the plumbing, and electrical, if you guys want tomorrow. Let's go over that. There's some interesting points where, for example, on the heat pump, instead of waiting for the siding and exterior to be finished, we can actually, one approach is you create modules. Well, obviously that, so the heat pump module could be like a window. It's you insert it, you frame the wall. So we're going to modify wall number, the one that's, actually, I was thinking about it for the workflow of the whole workshop. If you can build things sequence independent, i.e. modular, yeah, that helps. So it happens to be module number 6, but that module, we're going to put in a window into it, into which we put a whole structural assembly that's got the heat pump, interior, exterior, electrical, and connections and outlet, all that in one. It's going to be a heavy thing, but with a few people, we can actually carry it into place. And it would probably be too heavy for one person, but since this is a workshop, we can modularize that and make it a module that we pre-build in a controlled environment, not on the house itself, but we build it as a separate module in parallel with everything else. So tricks like that we can do, and we're planning on doing that. So we make sure we get a good modular experience. I'll go over some of the utilities tomorrow to show you how the modularity works in there, especially how the electrical, like we're running an electrical channel along the bottoms of all the modules, so that we're just not drilling through studs, because that's a lot. I mean, I think it's a lot of work. All the electricians say no, that's the way you're supposed to do it, but I think that's too much work, and it weakens the structure of the house. So we penetrate through walls only when we absolutely have to. Otherwise, we use a utility channel for the electrical, and it's much more modular that way. You can access it and take wires, switch out wires, and add wiring, things like that. So I'll discuss some of that tomorrow then. Okay, so I think we
Thanks,
can,
Ed.
yeah, we can leave it for here, unless we've got any more questions.
Change out
Jack?
the top plates. The
Go
top
ahead.
plates are different.
Sorry, say the question again.
Did you change out the top plates? Are the top plates different?
No, they're pretty much the same. That's that. Now there is, okay, so here's the truth. Because the house is designed for expansion, it has to have a certain height. So instead of, because now our the trusses that we did are as such, we raised the walls even higher to make the modules actually 10 feet. Ooh, so it's going to be a really high ceiling, because the addition in the back of the house that's going to be there also has to accommodate the roof slope, and therefore you need a certain amount of height on the front of the building. So that's what we're doing. So we're actually just redoing that. It's going to be much easier to do that instead of doing a structure on top of the 9-foot modules where you adding the additional height there. So that's kind of that. But the top plates, I mean, they're pretty much, in terms of just the top plate strategy, it's pretty much the same, because you still got to perform the same function. Yeah. Okay. How about Jackson?
Okay. I just wanted to chime in. I'm really interested in looking into automating the FreeCAD drawing and like sort of technical documentation. I was just wondering, Keith, if you wanted to sort of break out and sort of exchange notes on maybe doing with the SQL database and trying to get that going.
Oh, Jackson, you're a little. It sounds robotic. Hey, why don't you can just we can text back and forth if you want. Here, I'll shoot you my my number here in a sec. Hold on.
Jackson, you're talking about some automation. How can I help on that? What would you like me to do, or was that a request?
No, you're okay, Martin. I was just trying to get in contact with with Keith.
Okay. Yeah. Yep. That sounds good. Mm-hmm. Yeah. Sounds good. All right. So there we go. Yeah. No more questions. We'll go over the some of the modularity on the utility systems. Let's do that tomorrow, and we'll see you pretty soon. The game day is coming up pretty quickly. Okay. All right. Thanks, guys.
Thank you.
Bye-bye.